Today on SciGuys, acid-base indicators. Welcome to SciGuys. I'm Ryan.
And I'm Adam. Today we're going to be making an acid-base indicator using red cabbage.
Poiple cabbage.
It's called red cabbage.
It's poiple.
Its name is red cabbage.
Poiple cabbage.
An acid-base indicator is a solution that changes color in the presence of an acid or a base. It can be a sudden change at a specific pH or a gradual change through many colors as the pH changes.
The equipment you need for this experiment includes a couple of glasses,
A blender,
coffee filters,
and a funnel. We're also going to need a few ingredients from the fridge and pantry.
The items we need from the pantry are baking soda, vinegar, and distilled water.
The ingredients we need from the fridge include lemon juice and a red cabbage.
The last two items we need are ammonia and antacid tabs.
The safety equipment we're going to need today includes gloves, goggles, and an apron or lab coat to protect from spills or splashes. Also, since we're dealing with hot water and sharp objects, make sure you have adult supervision. So the first step for our experiment is to add 4 cups of warm distilled water to our blender. Next, we add 2 red cabbage leaves. Put the lid on securely. Holding the lid, give it a few pulses.
The second step in our experiment is to take your coffee filter in your funnel and place the coffee filter inside the funnel. This will help prevent any small pieces of cabbage from getting into our solution. Place your funnel and coffee filter over top of another container and pour your blended solution through the coffee filter. Make sure to take any large pieces of cabbage out before you start this filtration process. The third step is take your cabbage solution and pour it into several different glasses. Make sure to leave enough room for the rest of the liquid we'll be adding to test for pH. The first solution we're going to test is ammonia. When ammonia is added, it turns our solution a green color, which indicates that it's a strong base. The second solution we're going to mix with our indicator is a little bit of distilled water mixed with baking soda. The baking soda turns our indicator blue, which tells us that it's a weak base. The next solution we're going to add to our indicator is tap water. Tap water turns our solution a very slight blue color, but it still looks like a shade of purple. This tells us that the tap water that we tested is slightly basic, but close to neutral. The fourth item up for testing are antacid tabs. When we add a tablet to our indicator, carbon dioxide is produced, and because carbon dioxide is acidic, the color changes to maroon. This is not the end of our color change. Once our solution is done fizzing, the other ingredients in our tablet cause the pH of our solution to shift slightly towards a neutral pH, which changes the color slightly purple. Vinegar is our next solution that we're going to be adding to our indicator. When we add vinegar to our solution, it turns a very bright red or pink color. This color change means that vinegar is acidic. Solution number 6 that we'll be testing is lemon juice. Lemon juice turns our solution a bright red or pink color, which means that lemon juice is also an acidic solution. Let's look at this experiment a little closer. First, let's look at what pH is. pH is a scale that we use to measure acidity. The lower the number is on the scale, the more acidic the solution is. Water is a neutral solution and has a pH of around 7. Vinegar, which is one of the most common household acids, has a pH of 2.2. pH is determined by the number of hydrogen and/or hydroxide molecules a solution has. One of the ways that scientists determine the acidity of an unknown solution is with a pH indicator. There are many different kinds of indicators, but what they all have in common is they all change color based on the pH of a solution. The natural pigment present in red cabbage is called anthocyanin and is an example of an indicator. These indicators show the pH of a solution by changing color. When we add an acid to a red cabbage solution, we flood it with hydrogen molecules, which causes the indicator to change shape and reflect red wavelengths, making the solution look red. If we add a strong base, there is instead a high amount of hydroxide molecules, causing the shape of the indicator to change color and reflect green or yellow light. Solutions that are only slightly acidic or basic will change the color of the indicator to shades of maroon or blue respectively. The really neat thing about our cabbage indicator is that the shape of our molecule is reversible. So if we alternate adding acids and bases, the color can continue to change back and forth, provided you don't add a strong solution, such as bleach, that will eventually destroy the pigment completely.